22 of us. And,
I say we get started.
yeah.
Sure.
All
Yep.
right.
Yeah.
All
Hey,
right.
that's great.
Welcome
Next up,
everybody to
Sue.
our, hopefully what is our last Zoom meeting. We can at least be optimistic about it.
Right.
I like these. We need to keep doing them so I can participate.
Well, the plan is to keep doing them regardless of whether we have the meetings at Westchester
person.
or not.
Yes.
So that those that want to come in by Zoom can do so, or those that might have a little difficulty getting out of the house, or that, you know, just don't have the wherewithal to get in, can actually attend the meeting. So our plan is to continue it through the fall regardless.
Great.
Now, of course, I want to see you all. It's nice to see you in person, but
Yeah.
hopefully this COVID situation will have at least somewhat died down by the summer. So please do pay attention to the announcements, emails, and things that come from the various members of the executive committee, and we'll keep you posted as to what we're doing, especially come for the fall meetings. I would also like to put out there that last week, for those who didn't tune in, we have decided that we're actually going to try to stick to our July dates for the get-together up at Cherry Springs.
Okay.
We will, again, keep everybody posted depending upon what the situation is and what the weather is. But the park has actually been open for well over a month now. Astronomers have been up there observing on the observing field, so there's no particular reason that we can't. So we will keep everybody posted. If things change, or if there's a spike in the virus in rural Pennsylvania, that may change our plans. But like I say, we're just going to have to keep our ear to the ground and make sure that we do what keeps everybody safe. And we will also be informing everybody when, again, depending on the situation, when we'll get to our regular, you know, outside meetings at BVA where we can all get together. So with that, I'd like to ask any of the members of the exec committee if they have anything to report.
I have nothing new. Fortunately, the Bears do not get coronavirus, so we're safe up there at Cherry Springs.
All right.
I have nothing to report.
For Cherry Springs, Dave, I looked at the moon data, and if the weather's bad the week we have picked, the week after is also fine for the moon data. So we could go, if we get clouded out the week we have planned, the next week looks good.
Okay.
Ah,
We can go then also. So we have immediate backup the week after when we're planning it.
So everybody, please pay attention to your emails or however you get your, or the Facebook page or whatever else. And keep tabs on this. We would love to get as many of our members up there as we possibly can. And if nobody has any other announcements, I'd like to kick things over to our program chair, our incredible program chair, Bruce Ruggieri.
Oh, wait, doesn't Don
ta-da!
have anything? Any tour of the night sky or?
I will do a real quick one. Yeah, let me do that real quick. And we'll get
Yeah.
John going.
Sorry, Don.
I want to show you two things. One is everyone saw the launch, I
Yeah.
hope, of the
Absolutely.
SpaceX, yes.
Every
Like,
single
here-
minute.
There was a really cool simulator. All you have to do is search for Crew Dragon Simulator. It'll get you to this SpaceX site. You can all see this, I assume?
Yes, yes.
Click begin, just watch this.
Wow.
Whoa.
Woo, do, 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 do. And then from here, you can control and literally fly the Crew Dragon capsule into,
And you can try to dock it.
yeah, it is not easy. And it takes probably a half an hour to do it right. So anyway, I'm not going to do it now, but I just wanted to show you that this is actually pretty cool simulation. It is a lot of fun. So I'll stop that. And I will go to a quick look at Stellarium. We won't spend a lot of time on it. So we can get John going. Let me maximize it. Sorry. Everyone see my screen?
Yes.
Yes.
So this is a little bit ahead. This is actually for about 10:30 right now, which is about when it gets dark. Let's take a look in the, if I can turn this date and time off. There we go. Go to the west.
What's this?
Leo will be setting. Of course, some of our favorite spots to look at this time of year is the Leo triplet.
Yeah, it didn't fit in the containers.
Sorry?
Sorry.
Okay.
Yeah, I'm sorry.
Okay, Hamburger Galaxy is a little harder to catch, but these two Messier objects are pretty easy to see. If you really have a nice dark night and probably a good 6 to 8 inch scope, This is one of the most amazing sections of the Milky Way, which is the cluster of galaxies. You can spend hours in this section of the night sky.
Oh, yeah.
So
Don,
I was out last night. I was out last night for a while, and I spent some time looking for the comet, which I still couldn't see. And I spent some time looking here at Corvus. There is a NGC object in here that's not even showing. There it is. That is the Lawn Sprinkler Nebula. I
Serious?
did not see it. It's too light polluted for me to see with my big binoculars, but it was fun. The search. The search was fun. I zoomed up here to Ophiuchus. It's always nice to see M12 and M10 globular clusters. Let me center them. Globulars show up pretty well in the night sky, even with a little bit of light pollution.
which comet were you looking for, Don?
I was looking for T2 2017 Pan-STARRS.
Okay.
I've seen it up at the Poconos with a 12-inch scope, but I just couldn't get it here. So
Did anybody find, was anybody able to see Swan before it got dimmer?
it was, I didn't even try, it was too low in the
It
horizon.
was too low. I didn't know if it was me or, you know.
Yeah, down in the bush.
Here's one of our Madam Secretary's favorites. IC 4665, which is a beautiful, large open cluster called the Summer
Yep.
Beehive. It has a lot of similarity to the regular beehive. Not quite as showy, but a wonderful object. Easy to find off the shoulder of Ophiuchus.
Yeah.
Now here are the two. Here are the two that I wrote about in the June newsletter. All right, two clusters. The Tweedledum cluster.
Moving for me, Don.
And then the graphs cluster is also called the Tweedledee cluster. So Tweedledee and Tweedledum clusters. This is sort of considered the summer equivalent of the regular double cluster.
Don, it's not moving at all. Your cursor's moving, but we're just seeing the
You're
same.
right, your screen's not moving for us.
Let me close my
That's good.
browser. Not sure why that's happening. Well, I'm going to stop the share.
There's some kind of weird gray block in the middle of it.
Yeah, well, maybe it's just not enough bandwidth, so I'm going to close that out, and we'll just get on with the meeting. I think might be best, huh? So when we turn it over to John, I think everyone should stop their video and mute. If you need to ask a question.
He unmuted.
You muted.
I think Don just
What
left.
happened?
I think Don just. There he is.
Roger and Linda.
Hey,
Hello.
Raj. Hi, Linda.
Yep, we're here.
Hi,
Hey,
nice to see you.
We
Good to
heard,
see everybody.
Roger.
How are you doing, Roger?
how are
Good,
you feeling?
great.
Good.
It makes me happy to
We
hear.
hear that you had a unexpected visit to the hospital.
Well, that's because people talk too much.
Aha.
It's
But
because
we care about
We
you.
care, Roger.
No, it was, as I tell people, it's sort of like Marvin the Martian. When you see him and he's got the little duck down on the table and there's this giant piece of instrumentation that's up above and it comes down to a tiny point on the duck, and he says, and now we'll press the button. And so they just pressed my reset button and all was right.
All right.
Okay.
Good to hear.
Oh,
Good to hear.
Susan.
Hi.
Okay, so John, are you ready to start?
I'm all ready. Can you hear me?
Yep.
We can.
Everyone else
How's
can.
your leg? Or do we already do that?
So,
done it yet.
I just want to tell everyone, so, I don't think John needs any introduction, but it's just, he was supposed to give this talk originally in January, and he had an unfortunate accident climbing the Matterhorn. That's what his story is. And so he was kind enough to give the talk tonight. He's going to talk about NASA lunar science, highlights from Apollo, and lots of robotic spacecraft. So it's really good to have you on board, John. Thank you.
Thank you.
And if everyone else, please stop your video to give John all the bandwidth we can, okay? All right, John, so you know how to share screen now?
We're gonna give it a try here.
Down to bottom.
Yep.
And come up with a window and you'll pick your,
Can
yeah,
you see me there?
we can see you there.
Okay. Now Bruce may recognize me because we share a woods.
Yes.
We live on one side and here's a squirrel from our woods. Hopefully you see him. And is everybody seeing that?
Yeah, we see a squirrel.
Okay, that's Spencer. As was just alluded to by Roger, and Roger, I'm so glad to see you. I had a little mishap also. And so I was giving this talk in Radnor on January 10th, and it went really well. And I walked out in the dark and slipped on a very small hill and broke my ankle. And 10 weeks later, I got back to weight bearing. So I spent about 2 months longer than the rest of you being locked down. So that's my, going for the sympathy bid here. At any rate, we've all gotten a little squirrely and cabin fever here. So I just thought I would send you, let me get my screen fixed up here. How do I make the,
Looking right at me.
how do I make the thumbnails at the right go away?
I think
I don't know if it's me or this feed
not
that
sure.
you're
Anyway, if there's something on the screen that I can't see from my own slides, I'll ask one of you to tell me what it says on the right.
Yeah, I think what we saw is.
So greetings from our nut house. You may have forgotten what I looked like, but here I am, and I'm delighted to be back with everybody. And so we'll get started with a talk about what we understand of the good old moon that's really been added to our understanding because of the space age. So for the most part, this is courtesy of NASA, which has gotten the most for us about the moon. And we'll cover the manned and the unmanned. And as it says, it's just highlights because we've learned an extraordinary amount about this wonderful place. I want to note right off the bat that this is quite a unique view that you're looking at. And when I say unique, it's unique to Earthlings. It is for you and for your parents and grandparents and all of humanity, the only thing that we've seen of this nearest neighbor since time began, because the moon, as you're probably aware, is locked. And we only see the near side as it goes around in its period of orbit, which is known not coincidentally as a month or a month. And that's 29.5 days roughly while it revolves on its axis. So it's always facing us. And we didn't get a chance to see the wonderful other side here until the space age came along. And so here you see, and right off the bat, it's probably striking to you as it is to most people, how different the far side looks from the near side. And it's not the dark.
Are people seeing a news? I'm only seeing the chipmunk. Is it just me or is other people seeing the presentation?
I'm seeing the presentation.
I'm seeing the presentation as well.
Me too.
Good.
Check your view options up at the top, Ed. Might be something
Yeah.
to check the view options.
Okay, thanks. Sorry about that.
Okay. And incidentally, that was just fine to interrupt. So anybody has a question, just stop me. All right, so we're looking at the not dark side, but far side here. And that comes courtesy of the first visit, not by us, but by the Russians. So let's talk about that for just a second. Across the face of the moon here, and I assume you're all seeing the moon blown up here now?
Yes.
Looks good, yeah.
Is a summary of all the places that we have been with landers in that particular era of the space age. And so the red balls, you should understand first, are all Luna spacecraft, soft landers that were set up by the Soviet Union, because if you were around back then, you know that it was an extremely different time. And the Russians not only put up the first satellite, they put up the second one before us. They put up the first animal, the first human, the first woman. They had the first probe to successfully get to the moon. They had the first orbiter of the moon, and they had the first soft landing on the moon. And so Kennedy and then Johnson were absolutely convinced that if we didn't win this huge battle in this battle space, of the Cold War that things were going to continue to go downhill for us. So fortunately, we did get our act together in the 60s. And across the equator there, you see our landers. The yellow balls are our surveyors, just like the Russians sent theirs up to have a look around. And ours, as expected, surveyed the landscape. And you see a couple of the blue balls, which are the Apollo sites, overlaying the yellow ones, which means the surveyor told us this is really where we want to go with people. You also see a couple blue balls right next to the Russians. So we learned a lot from what they saw too. At any rate, you see 6 blue balls for the 6 two-man expeditions out of 7 that we tried, where Apollo 13 didn't get down there. And so that's the summary of how many people, a dozen people that have set foot on the moon. And here in one chart flat is a summary of the science. Each of these quadrants is a different parameter. Lower left here start off with how long they got to spend there. The last 3 missions all got to spend quite a while outside of the lunar module, about 20 hours. But the first mission, not surprisingly, because its objective had little to do with anything but proving that humans could stand on another heavenly object for the first time ever. And so they wanted to get the Armstrong and Aldrin crew back quickly. So they were only out of their capsule for about 2 hours. Along with that is the amount of distance that the different teams of 2 were able to cover. And it changed drastically after the 3rd mission because we sent a car up with them. And so having these lunar rovers, which are still up there, to drive around 15, 16, and 17 got to go 15, 20 or more miles as they did their exploration. The science was supported by a number of very carefully planned science experiments, basically, or science instruments is a fairer name, that they took along with them. The ones that I find to be quite interesting with regard to understanding the structure were the seismometers. And each of the 6 crews took along seismometers and emplaced them. So we have seismic measurements at 6 different locations spread across the near side of the moon. And I thought until last week when I was kind of brushing up on this stuff for the talk that that was kind of it. And then I learned that these guys had something else in order to not just calibrate, but look at the lunar structure and how it took care of the vibrations, in that they took along something called the thumper. And if you've ever heard about geologists, they go out in the field and they slam something big down on the surface and they look at the returns in order to explore for stuff under the surface. Well, the 2 astronauts on Apollo 15 and 17, I think, had a thumper. And it was this long pole that had explosive charges at various places on it, where they'd slam it down onto the surface in order to look at what the returns look like, which sounds like fun. They also had this thing, which as you look at it, you note it has a white base, which is pretty broad, and it has this angled thing, which is, believe it or not, a mortar, like you use in battle. And it was launching rocket grenades that would go a certain number of yards and come down to the surface and provide a seismic shock. So I don't feel as sorry for these guys anymore. They had a pretty good time up there, I think. Anyway, the best of the science came, of course, in that we were able to take this next door neighbor that we'd never been able to touch and bring back through the different missions bags full of rocks and soil to where we had almost a half ton of the moon back here on Earth by the time we were done. And we've learned an awful lot from that in the 50 years since then. All right, so that's Apollo. So Apollo ended, and I think most people, I wasn't quite a layman since I was in the rocket program with the Air Force, and I actually launched a polar orbiter from the West Coast 3 days after Apollo 11 went up. But I was watching with great interest and was as surprised as anybody that it wasn't just a little while, it was a quarter of a century before we went back to the moon. And the reason for that was quite simple. And it's the same reason as we do things when we can around our house. when the budget allows us. NASA had spent an extraordinary amount on the lunar program in the 60s, and it was somebody else's turn. And so between the space shuttle and the visits to Venus and Mars and the good old space telescope, nothing approaching the urgency of getting back to the moon again with an unmanned something came up. And so we waited a quarter of a century. And then in 1994, we did launch a spacecraft, and we've had 25 years then, which is literally a generation of robots that have given us the science since then. So here are those 7 spacecraft in the last quarter century. From left upper to right lower, it's chronological. The first 3 had a focus area, which, like the early missions to Mars, were very much about looking for life, but especially looking for things that could make it a better habitat. Maybe life, but certainly something that would help us if we went back there, and that's water. And so you'll see what these first 3 missions did, because we suspected there was water, even though the places visited by the Apollo astronauts had given us no reason to believe that or to find it. Then came sort of the granddaddy of lunar robots, just like MRO is a really big deal, the Mars Reconnaissance Orbiter. And so the Lunar Reconnaissance Orbiter went up and has been up more than a decade and is still operating fine, and it's just a great spacecraft. Along the bottom here, we'll talk about each of these briefly at the end. As opposed to searching on the surface, they looked for structure below the crust, and they looked at the environment above the crust. All right, so back to the search for water. So a way to think about how we thought this through, well before we went to the moon, even the first time probably, we thought about the fact that the moon is nicely tilted, pretty much like the Earth is, which is to say that as it goes around the Earth and the Earth goes around the sun, its poles are very often in darkness. As a matter of fact, the polar regions of the moon, if you go to a deep crater there, you're well below where the sun's rays can come. And these 3 different images of lunar craters from 18 degrees to 8 degrees to 3 degrees on the right grazing angle indicate the fact that if you have this low grazing angle where the sun literally, for the billions of years that these craters have probably been there, has never seen the bottom of a lot of the craters, it makes them a wonderfully cold place with no atmosphere to, if there are any volatiles, find them there, that they wouldn't have boiled off as they would have in other places. So that's what our spacecraft did. Clementine in '94 was the first one. It carried a radar. And so the radar was in an orbit such that it went over the poles and it looked directly into the craters, and it also looked at the regolith, the layer of crust and soil on the surface. And it got returns that were very nice and consistent with what ice crystals would look like with a radar. But the problem was there are other things that it could have given the same returns. And so it was ambiguous because it might have been just rough terrain. We didn't nail it down. Lunar Prospector went 5 years later. This time we had a spectrometer. And so this neutron spectrometer did map the polar regions, did find lots and lots of hydrogen. And that's great, except it didn't have a way to look for oxygen. And so it couldn't verify that it was water. So we had 2 strong clues. And finally, 10 years later, with something called L-Cross, we made sure to get back there and actually confirm that what we were finding was water. So L-Cross, as the C in the name indicates, was literally going to a lunar crater, not a bunch of them, but one of them. And it was going there to confirm that there was water of some form in that crater. And obviously it would be a crater very near the south or north pole. What happened was quite interesting. Again, I just learned this recently, but by the time it got there, I believe in, I'm going to say October of 2009, it had been scooped. And that is that there had been an Indian spacecraft, the nation of India, And we, as often happens, had an instrument on that spacecraft, and the Indian government also had some instruments on the spacecraft. And they had been up there in 2009, and they'd been gathering data. And the scientists reported out 1 month before L-Cross got to the crater 2 papers that confirmed that there was water on the moon. So it turned out that L-Cross, by the time it got there, it was just further exploring the confirmation. But it had other things to do too, and it was better at doing water. Now, the reason I have another spacecraft on the slide is because both these spacecraft were launched by the same booster and upper stage, which carried them both up into low Earth orbit, at which point they both separated and went their own way to the moon. And there on the right is the Lunar Reconnaissance Orbiter, which we'll talk about at some length, because it is not only has it been there a long time, as indicated by the open-ended date, it actually passed the 10th anniversary in 2019. It's now, I think, close to its 11th anniversary. And it has many missions that it supports and many instruments on board, 7 to be exact, only one of which isn't working anymore. So it's been fantastically successful. So let's take a look further at what L-Cross did to try to search and confirm water. Here you see a spacecraft. It's an upper stage that you may very well have heard of because it's been launched countless times since the first time around 1970, I think, which just indicates that when something works well, you keep using it. It's still being used, I think, sometimes today, but I'm not sure. But at any rate, in 2009, it was used, some 30 or 39 or 40 years after the first use. And it's a large upper stage. It's about the size of a school bus. There weren't any children inside. It had its own motor. That's what got it to the moon. And the whole idea was to use this as the mass to be slammed at high velocity into a crater. And so here's a picture of what the L-Cross upper stage did. And again, it's an artist concept. And the thing following it there was the other part of L-Cross, known as the shepherding spacecraft, which flew to the moon on top of that Centaur upper stage, separated before it got to this point, and then followed it in with its instruments, taking a look at what was going on. So here is what went on. Actual image of the Cabeus crater near the South Pole. You can see in the center there kind of a small fuzzy cloud, and I'm going to blow it up here, and you'll see that, yes, indeed, there it is. We've got some nice water spout coming up, but seriously, here is a blow up of that cloud with a scale. So you can see that it's quite a large cloud. And not only were we able to get visible confirmation of this matter that had been lifted into the air by impacting a mass of many thousands of pounds at about 5,000 miles per hour. But this came up out of the crater into the sunlight so we could see it. And the best of all was that there was also a spectrometer on board that was able to look at the constituents in the cloud and confirm once and for all that there was water in the cloud, both ice and water vapor, and use the estimates that they were able to make of the volume and the mass in order to estimate that every ton of soil in the base of a crater like that would have about 10 gallons of water. And there are a ton of craters, and so there is lots and lots of water available just in these craters around the polar regions. All right, so that was L-Cross. Now let's go on to LRO, launched at the same time in 2009, about the size of 2/3 of a school bus, with nice set of solar panels on the side for power and the antenna there for telemetry and data uplinks and so on. And on the side are these 7 instruments nicely labeled by the artist, of course. And so let's take a look at some of those instruments and see what they did. Well, where L-Cross had just confirmed water, LRO now was going to do more than just confirm the presence of it. It was going to look around and see just how much and where. And so there were 3 different instruments that were specifically set up for that. LAMP, the Lyman Alpha mapping project, as indicated by the Lyman Alpha wavelength, it was able to look into those shadowed regions, and using the light in the ultraviolet from stars, it was able to get enough light in those very dark regions in the right part of the spectrum in order for them to confirm and map water ice in lots of shadowed regions. Land is interesting partly because it's a Russian instrument. As I said, different nations fly on different nations' spacecraft sometimes. So they shared an instrument. ND means neutron detector. And so they have found lots of hydrogen and mapped those regions of it around the moon, and it's pretty extensive. And it is not necessarily a completely sufficient evidence of water, but it's one of the conditions. And so it gives us a hint of just how much water and where it is. The mini RF is much like Clementine. It was a radar. And so in this case, that radar not only was able to confirm the presence of ice in the craters, but find buried ice in the regolith, which is to say permafrost. And so there's lots and lots of water, not just in the craters, but in other areas in the cold regions. And then finally, relevant to water are the temperatures on the surface. And so an instrument called Diviner was a thermal infrared imager. And so through these many years, it's built a database where you can mosaic complete coverage of the moon and its thermal properties. And so here's an example of the kind of product that you can just go out on their public website. They have a nice online catalog, and you can pull these out if you'd like to. Here's a mosaic with these slices that weren't covered by the passes at that date, pointing in towards the South Pole. And the color coding indicates that from magenta to purple to blue are the various very coldest regions, not surprisingly, in large craters in that area. And as the words indicate, it confirmed and mapped widespread ice at the poles, surface deposits of water ice, including permafrost regions. One more image from Diviner, similar data, a little different color scheme, but the blues and the turquoises are the coldest areas. And the reason I wanted to put it up here was I've circled in that black there, the black circle is called the Hermite crater, not right at the pole, but almost at the pole, and permanently shadowed. And it turns out that we have found our coldest temperature anywhere in the solar system so far right there in that crater. And if you think about the fact that we've looked pretty hard elsewhere too, including looking at Titan, for example, which is 10 times further out at Saturn, which means being 10 times further out, 10 squared, means that it's 1/100th of the solar radiation that gets there. So it gets much, much less radiation from the sun than our moon does, and yet here's the coldest place right next door. All right, the other big mission for LRO, not surprising because the R in its name for reconnaissance is something we're all familiar with. When we want to look ahead to something we do in the future, we want to do some recce. We want to do some reconnaissance imaging or something like that. And so not surprisingly, we set up 3 cameras on board LRO. One of them's wide angle, 100-meter resolution is fairly crude. And yet it gives us a wonderful database now of the entire moon, mapped many times over, having been up there doing this for 10 years in a polar orbit with the moon rotating underneath. And therefore we've got multiple views of every place from different angles, which means that we not only have a complete view, but we have a complete view in 3 dimensions. And the narrow angle cameras give us some nice, really good reconnaissance imagery, like on the right here. One of the projects they did early on was to visit all the Apollo sites and see what they could see with their 1/2 meter resolution camera. And so that's about 20 inches. So for example, if you had a car sitting in a driveway, you'd easily be able to make out the shape of that car, or the presence of the car at least. Bicycle, maybe you'd see it, but not so much. At any rate, you're seeing in this image toward the middle, the top of the lunar module after the ascent stage brought Armstrong and Aldrin back. And you see these nice little dark lines going to the upper left to some experiments and the lower part, and also straight over to the right to a nice large crater, which is as far as these two astronauts got to go. And you see by the scale, they only walked about 60 meters away from their lander when they visited the first time. And it's really striking to see that when you don't have wind and you don't have weather, you can go back, as this did 40 years later, and the scuffing that you did with your boots in the soil looks just like you walked away from it now. So these scars are fairly permanent. Here's another image from the narrow angle camera. This one from the latest successful Chinese spacecraft. And the Chinese, I will note, had planned a series of 6 moon spacecraft, and the first 4 have all been hugely successful. The first 3 went to the near side. Chang'e 4 visited the far side for the first time. And in this LRO image of the landing site, which you'll see a little bit more of in a minute, on the left arrow there is the lander, and the right arrow is a little dot that is the rover, and you'll see that also. And it went to a place we're going to talk about some more called SPA, the South Polar Aitken Basin. It's going to become quite well known, I think. At any rate, there they are, having landed on the far side, January of 2019, still operating. All right, another sample of the reconnaissance kind of imagery, looking in a big crater on the far side. Within the crater, a range of mountains and a plain pockmarked with other smaller craters. And you get an idea of just how much detail you get if you're trying to plan a mission in the future. It's quite nice. All right, there's other kinds of reconnaissance as you scout ahead. And in this case, since we're talking about sending people, and the worst hazard once we get above our atmosphere is cosmic radiation out there, we want to understand what it's like on the moon. So Crater has been mapping the levels of it all these years, with the intent being to look for, any reasons that they wouldn't be just the same everywhere, as well as possible ways to shield future humans that might go up there. Again, we'll talk a little more about that. Finally, we're going to go back to Diviner, which was also used very much for reconnaissance, because you want to understand the temperature, certainly, but even the thermal properties around the areas that you're thinking of landing. And so here's a color-coded, again, available online, full moon image, where the equator goes from left to right across the middle, and it goes up to toward the polar region to about 70 degrees north, and the same down toward the south, and goes from 0 to 360 around the compass. And therefore it's just laid out as the complete moon there. So that's a kind of a nice indication of the complete temperature map we have for reconnaissance. And then finally, we have on board a laser altimeter. And you may remember that there's one that has flown for about a quarter of a century. It's actually 4 or 5 of them now that have flown around the Earth with different names. The recent one is called Jason. And Lola laser altimeter, like MOLA, which is the Mars one, and Jason, all are just a simple active radar pointed straight down, so that the time of flight for the signal to get down and come back to the spacecraft is indication of just how far it is to the surface. And therefore, as you do this for every point with the surface rotating as you go around in a polar orbit, then eventually you map out the entire surface's height. And so we're going to take a look at one of the key products of that kind of thing, a topographic map. Now, much finer scale versions of elevations are needed for and are available from LOLA for planning actually a specific landing site. These are pretty crude, but it's a really interesting way to look at the moon in terms of elevations. The center of the scale at the bottom, as you see, is kind of a light green to yellow there, which is the mean elevation on the moon. And remember, this is a body much smaller than the Earth. And yet you have elevations down to about 20,000 feet below that level, below the mean level, and up to, as you look at the highlands over here, up to approaching 25,000 feet above mean elevation. And so it's kind of striking, and there is a hypothesis for this. Some point maybe we'll prove it out some, but why would the far side have all the highlands as it does and much higher than the near side? At any rate, another day we'll talk about that, but it's interesting to me that you can go to the top of the highlands here, about 25,000 feet above mean elevation, and only go a few hundred miles south into the center of SPA, the South Polar Aitken Basin, and get to and go through an excursion of about 40,000 feet vertical in just that short span there. Now SPA, which is where the Chinese lander is going to be visited a lot, I think. It is the largest known impact crater in the solar system after all the bodies that we've looked at. And so you can just kind of imagine with the moon being born shortly after the Earth 4.5 billion years ago, and being molten for many years all the way out to the surface, and then eventually a hard crust formed maybe 3.5 billion years ago. And at some point, huge impacts took place. The impact that put this one here is really striking. You can see all the craters that have shown up there after that. And just kind of compare the depth of it from the color coding to what we see on the near side in the mare. So another look at the place where Chang'e 4, the Chinese spacecraft, has landed. It's in a crater called the Von Karman crater, which is in the SPA, and it's much younger, as you can see. And within that, you have the lander, but especially I want you to see here in a second the rover. And you see in the foreground there, I should say, you see at the bottom of those images, which are all provided by the Chinese since they landed, a view that looks much like the lunar rocks and surface on the near side. And then what you see in the upper right there is kind of cool. It's a wheelie being done by this little rover. And I love the name of the rover, the U-2. And it's the U-2-2 because U-2-1 is on the front side of the moon, where they put a rover there also. U-2 means pet rabbit, basically, in the Chinese mythology. And it was the pet rabbit of the lunar goddess, and the name of the lunar goddess is Chang'e. So now you know that part of Chinese mythology and where the names come from. All right, so one very interesting thing, remember that huge impact that caused the SPA basin. It churned up, we assumed, and now are proving with the Chinese help here, a lot of material that was way under the crust. And so the mantle material, they are now sampling and finding and learning things that we hadn't learned on the front side, and helping us to understand, as the cutaway shows here, the inner structure of the moon. All right, so just to kind of step back, we've talked about how airless and lifeless, and we might have thought waterless, but now we know that it's not waterless at all, but it is very dry. But it's certainly not activityless. And what I mean by that is this. Here you see being flickered two images. If you look at the codes on the bottom, you'll see that the one without the rays is from 2012 February. The one with the rays and with the crater brightly shown there in the center is about 15 months later in July of 2013. And lo and behold, this image pair was looked for because on March 17th of 2013, in between, an automated, I'm trying to remember the name of it. I think it's lunar and meteor sensing device that Marshall Space Flight Center runs from Earth. It watches the moon for flashes. Basically, it's looking for bolides. And so it saw one on March 17th, and it sent the LRO team with the imagery that they'd gotten after being up there for about 4 years to look for a temporal pair that could surround this location. And they actually found one that corresponds to the bolide that we gave these, that they have estimated these particular measurements to, about 10 to 15 inch, let's see, 0.3, 40, about 12 to 16 inch diameter meteoroid that weighed about, what is that, about 100 pounds, created about a 20-meter diameter crater. And so this is just one example of what we were able now to look for and find with the LRO imagery database, where you visit the same place many times. And so not coincidentally, but by plan, they try to visit the same places with the same sun angle so they can compare images. And so the computer helps them to find images and then register them so you can compare them and look for reflectance changes in the difference image, if you will, or between the two images. They did a study on it, and they may have done one lots more recently, but the one that I got a talk on from NASA was back in 2014. They told us about a study where they looked at, I forget how many thousands of pairs over a 27,000 kilometer squared study area, which sounds like a big area, but it's about 0.1% of the total moon. But the images were located nicely spaced across the face, so it's a good representative set. And after going through that and finding changes in reflectance, what they found was over 300,000 lunar impacts per year when they extrapolated out their results, which is quite extraordinary. I think the number was 317,000, but 300,000 is close enough. And greater than 800 a day when you divide by 365 is therefore what the moon experiences in terms of something that changes the reflectance. Maybe it's a big meteoroid, maybe it's a smaller one, maybe it's ejecta from one coming down somewhere else. But at any rate, the US area is about 1/4 of the lunar area. So that's equivalent, just thinking about it, to having 200 impacts somewhere in the US every day. And that doesn't happen to us on the US. And it's exactly the same neighborhood of stuff flying around that the moon is. But what's different, of course, is our atmosphere. And so we can be very thankful for it. Lots of stuff happening on the moon. And this shaking, which was measured for years by these seismometers that were put up there by Apollo, is an indication of vibrations caused by meteorite impacts. And there are other kinds of vibrations going on, although we don't believe there's plate tectonics. We do have a particular kind of quake, which is quite different than we have on Earth. And so I want you just to think for a minute about a day on the moon. Any day you're on the moon, if you're in the sunlight, then you're going to spend half of your period, and your period again is a month. And so you're going to spend about 2 weeks in sunlight without any atmosphere blocking anything. Then you're going to go through the terminator and instantly be staring into deep space and all that cold, and getting colder and colder for 2 weeks until you do the same thing and come through the terminator and instantly come into the sunlight. Well, when they instantly come into the sunlight, after the crust has gotten so hard for that 2 week period staring at space, things move fast. And there's lots of expansion right by the terminator. and you get thermal quakes that can be registered on seismic instruments from that. And then you get just good old earthquakes, which are called moonquakes up there. And some of them are deep, and the deep ones are caused by the tides. And so this kind of causes you to recalibrate what the word tide means. It means a water thing if the body happens to have water that's attracted by another body and moved up and down by that, as our water is moved up and down by the moon's attraction. But in the case of the moon, it's simply the fact that the moon isn't solid hard, just like the Earth isn't. And the Earth and the moon both are somewhat lumpy in terms of their mass. And so the Earth is rotating every 24 hours while the moon is going around more slowly. And as we rotate, literally every place on the moon is seeing cycling of what it senses as the Earth's gravity, as the Earth rotates around with different kinds of lumpiness. So hopefully that helps you to kind of picture the push and pull that causes some deep movement in the moon, down maybe 90 miles deep, some of these moonquakes caused by these tides. The shallower ones, more like the Earth ones, we really don't understand what's causing them. They are the strongest. We've had measurements up to about 5.5 on the Richter and more than 10 seconds for some of these shallow moonquakes. All right, so a little clue here to what comes next. Good old Spock, what was he? Well, he's a Vulcan, of course. And so now we'll talk about volcanism, this kind. Simply volcanoes and the magma and what they do to the land. And so our lunar science now, especially due to LRO, has allowed us to do lots and lots of surveying for different kinds of volcanism. And we'll go through them in turn here. Large volcanoes first. So large volcanoes, well, you probably haven't heard much about volcanoes on the moon. I know I haven't. And the fact is that the lunar mountains, which were mostly formed long ago, weren't formed by volcanism. Unlike Earth, where we have lots that were, in the case of the moon, they were almost all formed by impactors of various sizes. So we've got the big basins that have become the mare and so on. And we've got many, many smaller craters. But in many cases, as the right-hand image here shows, for some of the biggest of these, that little arc indicates just how huge that impact crater is. I don't know which one it is. But along the edge, the material gets pushed up and forms a mountain range. Over on the left, you see another way they get formed by the material that gets thrown up in the air, ejected, and then comes back down and piles up. But that doesn't mean that there aren't volcanoes on the moon, it turns out, although 50 years ago that would have been not thought to be so. But what we've found now, and what we're surveying more with LRO, is recent mountains. And by recent, I mean maybe within the last 100 million years. And recently, in the last 30 years or so, the scientists have started to conclude that we have things like what we have on Earth called shield volcanoes. Basically, it's a volcano that doesn't erupt so much as just have a fissure that opens and pours out lava. And then after a period of time, maybe pours out another layer. So they're like layer cakes almost. On the moon, they make even more smooth and domey looking things because having so much less gravity on the moon, a volcanic eruption is quite a different thing because it doesn't get brought back down to the surface as it does on Earth when lava gets spewed out as fast. And so things are much gentler in that way. At any rate, the kind of volcanoes that we've been finding now are like this one on the left there in the Gruithuisen crater known as Gamma. And so Gamma, despite the fact that you see something that looks for all the world like a volcanic crater in the middle, that's actually where some meteor hit it after it came to this shape. But at any rate, it's layers and layers of lava that's just oozed out and grown up to this height. 3,000 feet. There are mountains caused by the impacts that are upwards of 18, 20,000 feet, I think. Okay, so to finish this up, as we have come up with the phenomenology to create the domes, we've looked for sites that we believe might be those to visit. And here are a number of them that LRO has located through the years. The next Chinese spacecraft is supposed to literally land on one that's, if you look at that box on the right where it says near, right about under where the letter N is about where the Chinese spacecraft's going to land. Chang'e 5, which was supposed to be launched this year, and I think it's going to be launched next year. So the Chinese are busy. They're going to visit a dome pretty soon. Pyroclastic deposits are another kind of volcanism. And the name kind of says what it is. Partly, pyro means fire, and clastic means sort of structural. So it's deposits of material that are put into a structure by fire, like this. And that, of course, is an eruption on Earth. But it gives you an idea that when you see soil with little grains that look like that color, maybe you've got the same thing. And when I say little grains, it might look like these are like little orange marbles kind of that you could put in the palm of your hand, but the scale is 0.1 millimeter there. And so it's like it's like a little handful of sand. And this particular handful of sand came from right here. The last of the Apollo missions, I think you're aware, was the only one that had a scientist. And since we were trying to understand this body and how it got to be that size and shape and everything next door to us, sending a geologist was kind of a no-brainer. So Jack Schmidt got to go up there, and right towards the end of their mission, this guy that never could have imagined flying in space is up there, and he's walking around just before they were going back to the lunar module to fly home. And they hadn't found some stuff he was looking for, and he scuffed the surface and looked down and just exclaimed that it was ruddy material, red material. And so they had finally found this kind of pyroclastic deposit that he had hoped to find and hadn't yet. He took a bunch of pictures of it, which didn't turn out to be anything but very fuzzy because he was shaking so much because he was nervous and excited. But Eugene Cernan, like the rest of the other 11 Apollo astronauts, was a test pilot who was a cool head, and he was with him. And so he had him put up a little color scale there and kind of pose. That's not him literally posing next to it with his helmet off, but they posed this whole picture and took a bunch of pictures of the in situ deposit there. After they brought it back, they analyzed it and dated it to be about 3.6 billion years old. All right, another kind of volcanism with a kind of an artistic name. Rills are a feature well known to geologists, and they look for them on different heavenly bodies. And when we find these kinds of things, which we find on Mars, for instance, and on Earth, which you might call a creek bed or something, we try to understand how it got to be that way. So here's one in a crater on the moon, but here's a more famous one called Hadley Rill. And Hadley Rill, this little sinuous or snake-like feature, was seen prior to the Apollo landing sites being selected. And they were so excited to see this in the Hadley crater in the mid-60s that they decided to send one of the missions there to see if there was any evidence of what, if they could figure out what flowed there to cause that in the past. And so here's a picture of the rover and one of the Apollo 15 astronauts standing on the rim of the Hadley Rill there. And there's a nice close-up picture of it. And what they confirmed was that it never had anything to do with water. It was only about molten lava. And it was unlike Mars, for example, where we find evidence of flowing water. All right, so finally, Volcanism is well known and well observed by us on a regular basis in the mare. In these giant craters created by giant impactors long ago, the lava flows through fissures and fills up these craters to a large extent, as it has for all the well-known mare that we look at there. And it's quite interesting to see the smoothness of the mare, as you might imagine, flowing material with nothing disturbing it. And so you've got these mare, which they aren't mirrors exactly, but they're quite smooth to energy that impacts it and is reflected away. So for example, anytime that you're looking at the moon, except at full moon, and at full moon, the sun's behind us, and so pretty much all of the moon's being reflected back to our eye. But when it's not full moon, the sun's off at an angle, and as it hits the smooth surface in the mare, the light, for the most part, is reflected away from where we are. And so these dark mare have a reason for being dark. That's one of the reasons. All right, so we've talked through these four. Turns out in the last couple of years, they've come up with another phenomenon that they're studying now. It's not necessarily volcanology. They're trying to figure out what it is that causes lunar pits. And these were in the news in the last couple of years, or 3 years, I think. There are a bunch of them. The pictures here are all the same one. It's one that's in the Sea of Tranquility. And they've studied it a lot at different sun angles. And it's essentially an almost circular feature where the material on the surface is just dropped straight down and left a straight hole with the floor some distance below it. In this case, it's about 30 stories down. And we're only able to understand so much of them because you need a combination of sun angle and angle of the sensor in order to see what's in there. We've studied them in terms of surveying all of the imagery we have to find them, and we found more than 200. And we found that most of them aren't in the mare, like you see here in the right. They're in the impact melt, which was something that was a name I wasn't sure I understood until I read a little about it. And you think about it, and when these impactors make their craters, there's so much energy released, so much heat, that the material on the side of the crater is literally molten and melts and then hardens up. And those are the areas where most of these pits are being found now. We don't know exactly why the surface basically crashes down like this, but we do want to understand them. We do want to actually go to them and survey them on foot, because if it turned out that they either communicated some way with a lava tube, say subsurface, like on Earth, where we have lava tubes that make wonderful caverns and caves. But at the least, if they clear out a path where you can get underneath the lip some distance and have the surface layer shielding you from cosmic radiation and solar radiation and the day-night cycle and so on, that would be a really nice thing for future explorers to have as a haven. All right, so one last feature, geologic feature that's again been studied more recently. It's known as a scarp, which if you studied geology at all is a fairly familiar term. As you think of 9th grade science and what you learned about expansion and contraction and temperatures, you know that any object, for the most part, will shrink as it cools. And the moon is warm in the center. We don't know how hot, like the Earth is. And the crust, as I said, maybe 3.5 to 4 billion years ago, somewhere in there, it hardened up. And everything underneath it has been cooling ever since. And so as the material under it cools inside in the mantle, it shrinks. And at some point, the surface is a little too big for itself and it cracks and the crust folds over itself, buckles. And scarps are these cliff faces that are formed then. And so we've mapped a number of those now, lobate scarps they're called. And one of the things we're learning is to date them according to finding craters along their edge that either indicate that they were there before the cliff formed or showed up after the cliff formed. And so if we can date the craters, then we can start to date the scarps. All right, so we're finally done with the surface. We're going to go above and below here with these 3 other spacecraft that have all flown in the last 10 years. All orbiters. As a matter of fact, of the 7, the only one that wasn't an orbiter was L-Cross that crashed into Cabeus. So first we'll look at Grail. And Grail might look familiar to you if you remember Grace. They're identical constellations. Grace goes around the Earth, as does Grace Follow-On, which is flying now, and senses the Earth gravity just as Grail does the same thing around the Moon. It's 2 identical spacecraft, not connected by anything, but communicating with a microwave signal that gives them an extremely precise measurement of the distance between them. Because one leads and one follows in exactly the same orbit, and therefore the leader, if there's a change in the gravitational attraction of the mass underneath it, will sense that gravity change before the follower will. And if it's higher mass, it'll probably accelerate it as it approaches it. If it's lower mass, it'll do the opposite. And so the distance between the 2 spacecraft, sort of like an accordion or a spring, will go in and out, and they can take those measurements and they can back them through a whole bunch of math into a model of the mass of the attracting body, the Moon. And so here is a gravity map where the bright reds are the high mass regions and dark blues the low mass. And we looked for this and expected to find it, maybe partly because we'd already seen some of this with the Earth, but partly because of what happened with Apollo. Apollo had, as I said, 2 men on the Moon and 1 man orbiting in the command module while they were down there. And the orbits of the command module didn't follow what all of our orbital mechanics said they would if you had a perfectly homogeneous Moon. And so the lumpiness of the Moon we expected to find because it kept changing the command module's orbit slightly. And we did find these mass concentrations, or mascons they call them. And we were able to correlate some of these also to large asteroid impacts. Next, we have the Artemis, which is a name that you are getting familiar with because NASA forgot they just used it and used it over again for the current Moon program. And so with some amount of, no apology, but at least some visibility, they've come out and had press releases to rename it Themis Artemis. And so you can look this up in Wikipedia now by that name. And you see what Artemis stands for there. And what it actually means is a pair of spacecraft in lunar orbits, and they're still flying and getting data today, I think, about 7-8 years later. They're getting data about the solar environment in the sense of the solar wind and the lunar magnetic fields as it interacts with that solar wind, especially in the tail as it goes past the Moon. And so they've learned a lot from that, but perhaps the most interesting thing they've learned, which I thought you'd like to hear, has to do with magnetic fields on the Moon. Now, the Moon doesn't itself have much of a magnetosphere, or large magnetic field, but we have now discovered with Artemis data that seems to indicate that there are small magnetic fields that are local on the crust. And so kind of picture it like going back again to 9th grade general science, bar magnets and iron filings and stuff, and the way the field lines go. So where the bar magnets poles are, next to another opposite pole of another bar magnet, the field lines from each of them come down to the surface there, and therefore the solar plasma, which is electromagnetic, can get to the surface there. And so what they're trying to correlate now is that there are actually scars that are cosmetic scars from the plasma density hitting the surface there, as opposed to other areas where the poles aren't together and where the field lines don't come down to the surface. And they're calling it lunar sunburn. Now, I emphasize the word hypothesis. This hasn't been proven. There are some indications of it. They're trying to gather enough, clues from images as well as measurements being made by Artemis to come up to something called a finding. So far, it's just a really interesting hypothesis with some evidence of visible places on the moon. And the counterpart to that, where the field lines rise up away from the poles, blocks the plasma. And they're imagining that perhaps humans should go to known places where there are lots of these magnetic fields that are higher up, which will block some of the plasma from hitting them. And sort of a lunar sunscreen, if you will. Again, just a hypothesis, but kind of an interesting one. And so finally, we come to the last of the small spacecraft, LADEE. And this little spacecraft has got this name with A for atmosphere in it. It might better be called LEDI because atmosphere is a little bit of a misleading name for the moon. It's a very tenuous, what we call exosphere. But at any rate, there is something to it, and LADEE was there to measure it and to analyze it. And you see that brown box on the underside of it there sticking out. That's a collection box. And so as it went around in its low moon orbit for some months, it actually would capture whatever it was getting in the sensible atmosphere. And there's a mass spectrometer in here also. And so it was able to analyze the constituents of the lunar atmosphere. And there they are. Helium and neon were not a big surprise because we've known for a long time that they were major constituents of the solar atmosphere, and therefore the solar wind would carry these. But the third one, argon, we had to kind of scratch our heads. It turned out that it's a radioactive decay product naturally of potassium. And so potassium under the crust, we believe, has ended up with argon that has gotten into the atmosphere here. And one other final kind of interesting, again, it's part hypothesis and part finding. They looked for a cloud layer, I shouldn't say cloud. They looked for a dust layer around the moon because every astronaut got to know just how much dust there was. And some of them reported that as they looked towards the horizon, they wondered if there was a layer of dust surrounding the moon. It turned out from LADEE, there's no evidence of that. There's plenty of dust. And what they did observe, since there's no atmosphere that blocks anything, lots and lots of tiny meteoroids, sometimes in streams, would come into the surface and kick up quite a cloud of dust. And they would be able to observe it and watch it as it would either fall back to the surface or be ejected, with the weak gravity out into space. And apparently about a third of it gets back to the surface. And it's made them wonder if, since many meteoroids have got some part of water in them, some amount of water, if this isn't a way that the water vapor that's in those micrometeoroids as they get deposited on the surface might not be something that replenishes the water on the moon. All right, so 25 years of learning from our spacecraft, which I will note here is the robotic spacecraft, and I'm ready for any questions you have. And I'm wondering, is there anybody there?
Hey, John.
Yes, we're here.
Yeah, we're here.
Yeah, we're here.
On that one slide you showed with the blink where it showed the new impact crater, it looked like the ejecta was equally distributed around us. So do they think that it impacted like 90 degrees, or could you detect any glancing angle on that picture?
Yeah, let me just go back there for a second. Easy to
The
say.
ejecta looks very well distributed.
Yeah, the rays were all around, and I actually have some. I'm gonna look at my notes. I have some notes for this one. Just a second. Let me get there. Almost there. Here we go. Okay. I'm gonna do this. I'm not sure. Okay, I see what happened. You can't see, what do you see right now?
We don't, your screen share stopped, so we need to
Okay,
share your screen.
that's okay, because it lets me read the notes at the bottom. I'll get back on in just a second. Let's see. March 17th, bowline. They saw the flash from Marshall. They looked for it, estimated this, estimated that. I thought there was something here about distances. Just a second.
You can start videos again if you want and bring
Here we go. The longest ray goes about 35 kilometers away, and the farthest that one of these little secondaries landed was about 113 kilometers away. Secondaries being ejected chunks, I guess. So they found some correlated low reflectance changes apparently. But that didn't tell you anything about the symmetry. I don't know, Don.
Here, it looked like it must have hit like straight down.
Yeah, let me get back on here.
You can share that again if you want.
Yeah. Here we go. Or did I share? There we go. How about now?
Coming up.
Hmm?
It's
Is it back?
Yes, it
yeah.
is.
I think you need to extend your advance your slide. We're in black.
I'm trying.
There we go. Okay.
Okay.
Yeah, it looks like it's totally symmetrical, doesn't it, to me?
Yeah. It's hard to say. I don't know.
And there have been some amateurs reporting seeing some impacts, I believe, not too long ago.
Yes, in fact, I've read that there are amateurs that watch the moon a lot that say that they see these little tiny flashes, that their fellow amateurs said, you're nuts, you're just seeing things, it's averted imagination and everything else. But this has borne it out that actually amateurs can see these things happen on the surface of the moon if they're looking carefully enough.
Cool. Yeah, neat.
So anytime our club members are out there with their small to medium-sized telescopes looking at the moon, hey, sometimes you might be, who knows, you might be able to see one of these things.
Great presentation, Sean. Thank you.
Yeah, really nice, John.
Thank you very much.
Thank you so much.
Hey,
Any
John,
questions?
John, I have a question. The
Yeah.
localized magnetic fields that you talked about,
Yeah.
I don't recall. Did you say any thoughts as to how they arise? Because the same thing is thought on Mars, that it doesn't really have strong magnetic field, but there are localized areas of magnetic field. So I'm just wondering what the thought is behind them.
I will look into it, Bruce. The answer is I don't know. I think I may have read something about it. Obviously, it's not the, what do we call it with Earth? The dynamo effect of,
Right, molten core,
iron bearing rocks, and stuff like that. I don't know. I'll see what I can find.
Just for your gut feeling, John, do you think that the Chinese are going to be the nation that'll put the next man on the moon?
Yes, I was going to ask as well.
Wow. Your guess is as good as mine. I know that they're 4 for their program, and the next 2 missions are well planned, and neither of them are manned. But the pipe dream of 2024 for us is not a real thing to beat, I don't believe. So they've got some years to go here.
Well, the reason I'm asking is that one of their missions that they're planning is, I believe, returning samples.
Yeah.
Right.
Which means they need to be able to dock with a ship in orbit or, and those are all the problems that we had to work out before we could put a manned lander on the moon. It looks like they are doing their, they're doing all their homework necessary in order to be able to accomplish just that.
I agree. I read about the Chang'e 5 mission today, the one they're going to fly, and it's just exactly that. So if they succeed with that, and they could within the next year from what I've read, that will have checked a number of boxes.
So you think it's possible? Maybe.
I sure think it's, I think, sure. Yeah. I mean, they learned and learned from us. Now, they have very recently struck a deal with the Russians. I don't know if you read about that. Trying to remember. It's all on paper at the moment. There hasn't actually been any exchange, but it is quite an interesting thing that just as we worried like crazy about that in about 1960, before Mao and Khrushchev had a falling out, we were really worried about the Chinese and Russians getting close 60 years ago. And then they weren't through the decade of the 60s and haven't been back. But now, maybe even stimulated by what they view as the weakness of their common enemy, they seem to be at least making noises about collaboration. And it's an odd thing. I was going to say the Russians may be able to learn more than from the Chinese now than vice versa, but I think probably it's about equal. The Russians haven't forgotten anything they've learned, and they have a longer space program than anybody. And the Chinese are going to make something of that, I think.
Cool. Thanks, John.
Yeah.
John, one last question. You continue to sound very doubtful about Artemis. Any specific reasons why you're so not optimistic that that'll be successful?
No reasons other than experience and and political observations.
Yes.
Okay.
Okay.
I will say
Enough
this.
said.
I will
Enough
say
said.
this. I will say, no, I want to say one thing. I want to say one thing, and that's a disclaimer.
Okay.
I know absolutely nothing from NASA about Artemis. Okay.
Uh-huh.
They haven't given us any meaningful presentations about it. Everything that you read that, whatever his name is, I forget the administrator's name, Bridenstine. Whatever Bridenstine says, whichever guy was fired that was experienced that they recently hired, which has happened now multiple times with their human spaceflight programs, NASA's. There are no strong indications from the old hands that this is something that there's any high probability of. My reason, though, is simple. They have a huge booster rocket, a huge unmanned or a huge spacecraft that's to be manned that's never been flown with people, a huge lunar orbiter challenge, a lander challenge. I mean, we're 3 years away.
Right.
And these are all the kind of missions that if you had any one of them, you'd be eager to get it done in the next 3 years.
Right.
And so as an engineer, I think it's a pipe dream.
Right.
And it'll be interesting to see just how much of it shows up in the campaign rhetoric. I mean, you saw Trump, you may have seen Trump's address after the lunar, the SpaceX launch. I saw one, and I think it might have been an official government one, but it might have been the one that's the campaign ad that they had to pull back because he did things NASA doesn't allow in terms of releasing information and showing pictures. I don't know if you all read about that, but it was quite a debacle last week.
Yeah. Right.
Anyway, it's yet another distraction, I'm afraid. What I'm worried about is how it will divert the focus that's needed on any large program to keep it on track.
Right.
So we'll see.
Yeah. Okay.
Wow. Great presentation. Thank you.
Yes. Thank
Thank
you.
you very much.
Yep. Great to be here.
Thanks again, John. You've given us so many great presentations over the years.
Yeah.
Appreciate that.
Much appreciated, John. Thank you.
Hey, I'll tell you, locked up here, it's fun.
Yes.
Ask me again. I'd love to see you guys too.
Yeah.
Okay,
Well,
September.
I hope your ankle is completely healed by now.
Hey, I am walking a lot, so
So-
it's getting there.
How many miles you're logging a day?
No, I'm not miles yet. Not miles yet. I did a third of a mile a few days ago. It's the farthest I've gone. I'm getting back on my Nordic track skier, which is a good thing to do.
Okay. Was your ankle barking at you after that third of a mile?
No, but it's so swollen. I mean, that is the problem. If you ever had one of these and then read about them, especially for people in my senior stage of life, the swelling takes forever to go away, and it's a lot. You know, I'm still wearing a big strap shoe on that foot.
Well, if Bruce has a pool, go stand, just stand in there with your leg as far down as you can get there and still breathe, because that's that ambient pressure around it is wonderful on that edema.
That's good. That's a good idea. Okay.
Okay, got to get a pool now. Okay.
Yeah, Bruce, hurry up.
I'm going to go to tell Janet I'm going to be taking baths morning, noon, and night. This is good.
My wife wishes I would.
Hey, great to see all of you.
Yeah. Hey, Dave, one announcement. I'm starting to plan for speakers for September through November. So if anyone is interested in giving any talks at any of our fall meetings, please send me an email, let me know. Or if there are topics that you're particularly interested in, let me know, because I'm seeking out, specific kinds of speakers from the local area. So I'll get a little bit of time, but just give me an email and let me know what you think.
Okay.
Thanks.
Do we keep a consolidated roster of who spoke and when? I mean, obviously you can go back over the newsletters and the website
Well, I have listings and stuff, and I'm sure Dave does. I mean, I know I have listings, and I have listings from other societies and contacts. So, I
I'm
could always
just
go back.
wondering how often can we hit up, our local resources, without them saying like, I just spoke last year, I'm not doing it again. I mean.
No, some of them don't mind, honestly, speaking once a year, especially because in all likelihood, they'll speak on a different topic of interest.
What about like Derek Pitts or someone?
Yeah. He's hard.
We were lucky to get that one.
Professors, they get credit.
I can't get my video back.
Not in money, but in terms of
Hey,
that community outreach. That counts.
hey,
There's a kitty.
There he
Oh,
is.
there's an orange kitty.
Orange
on-
guy.
on time. It's almost 9 o'clock. This is when I normally would be finishing teaching, and here he is ready for his snack.
You're out of luck.
He has you well trained, really.
He has us, yes, he does. Oh, here comes Crystal too.
John, you've got sucker written all over your forehead.
Oh, yeah, well, financially destroyed sucker too, yeah. Crystal's here too somewhere, she is. Oh, well. She's
Well,
down-
Susan, as far as I remember, and Linda reminded me, that actually college professors get actually credit for community outreach whenever they make a presentation to a place like our club.
Right. Right.
That's true.
And
If it's
grads-
in their, if it's in their area of expertise.
Yeah. And grad students are always looking to build their CVs too.
Right.
Yeah.
Yeah.
And we've had grad students in the past, and they've given, very, very interesting and presentations too.
Well, I'm actually trying for some speakers that are a bit of a distance away. And the thought is, there may be times when like now, we won't have an in-person meeting, we'll have a Zoom meeting. And we can have someone from, a distance. So
That's true.
Well,
That's a good thought.
it's interesting that that model is changing incredibly rapidly
Everywhere.
because of just because of this situation,
right.
that things that weren't possible before, you can't pay the airfare for ... or you can't pay the accommodations for ... But I just saw a presentation actually last night that was one exactly like that, an expert in the field that didn't have to go anywhere.
Right.
To be able to zoom in and do a presentation for a very specific group. So that's something, Bruce, that I'm sure that dynamic has changed just in the past half year.
Right.
Is that Crystal?
This is Crystal Caring.
Enjoyed it. Said he'd be willing to do it again.
Oh, Indian guy.
She's pretty, yep.
Where did everybody go?
They're here,
Oh, they're
They're getting out.
poultry too.
except most of them are still on mute, so we can't hear them.
That's right.
Dante wanted to meet the cat.
Oh, wow.
Oh, what a pretty bird.
Oh, how
Yeah,
cute.
my cats would like to meet Dante too.
What did he say? What
Huh?
did he say?
I can't get my camera back on. It won't start. Oh,
He
well.
just turned 29.
My goodness.
Serious? Holy
He's still a young one.
How
Wow.
long do they live?
Well, if you feed them right, meaning not just seed, to give them a variety, they can live 60 to 80 years.
Yikes.
Hmm.
Oh, yeah, parrots, yeah.
And how long have you had him?
Let's see, I got him when he was 1.
Oh,
Yeah.
wow.
Yeah, so 28 years.
Wow.
Hey, why am I keeping cats? They don't live that long.
That's right.
No,
Well, I looked into getting a parrot years ago, and when the pet shop owner told me, like, well, you're gonna have to put it in your will who's gonna take over care for it after you're gone. I thought, I don't think so. Yeah.
Yeah, that's a little unsettling.
They grieve when owners pass. So yeah, you do have to find a place for them. So luckily my daughter, she's in.
She grew up with
Oh,
him.
Yes.
the heck
yeah,
with the
yeah.
parrot grieving. I would grieve for the pet if it died after so much time.
Oh, well, absolutely. Yeah, yeah.
You
So
have a heart of
tomorrow,
gold, Dave.
my daughter turned 27. So Dante was a year old. I was 2 years old when my daughter was born. So
Wow.
Yeah, I know.
You can't see it, so.
Yeah. Well, yeah, I don't know. Yeah, it's acting weird.
Well, it's a beautiful bird.
thanks.
Yeah, it's a clear night out there. I think I got some double stars in my eyepieces later tonight.
There you go.
I think I'm going to be out there with the scope too, Don. I'll be joining you.
Yeah.
I'm going to be out there too.
Yeah, don't you pull that Unitron out if you're going to bring clouds on us all.
I know.
Not many nights this clear around here, so you gotta take advantage of it.
Usually with that, it takes a little bit of time setting up, so.
Well, set up quickly so that the doggone weather gods don't jinx us.
All right.
All right, guys, take care and we'll be in
Good night,
touch.
everyone.
Bye-bye.
Thanks, everyone. Have a good night.
everybody.
Bye.
Bye.
Bye.